On the last video, we talked about techniques 1, 2, and 3 for finding limits. So we got direct substitution, cancellation, and rationalization. This time, we're going to be talking about techniques 4 and 5. The first one, number 4 being technique number 4 will be to simplify complex fractions. Complex fractions meaning we have fractions inside of fractions. So here we have 1 over x plus 4 minus 1/4 all over x. So if we try to evaluate this limit as is with direct substitution, it would end up being 0 over 0. That being indeterminate, so it's not telling us much, so we got to try and use some math techniques to find a different answer. So we can start to try and evaluate this limit by first trying to simplify the fraction. So, to simplify these fractions, we can't combine them right away because they don't have like denominators. So to make them have like denominators, we're going to multiply by the GCF. So we're going to multiply this fraction by x plus 4 x plus 4. And this fraction by 4 over 4. Alright, now that we have common denominators, we are allowed to combine the numerators. So we have 4 minus x plus 4. So if we were to distribute that negative to both terms, that would be 4 minus 4, which is 0, so I'm not going to write that. Then negative x. So we have negative x, 4 x plus 4, all over x. Okay, so now we have just one fraction over a denominator. So, easy way to simplify that is when you're dividing by a number, it's the same thing as multiplying by its reciprocal. So I'm going to say negative x 4 x plus 4 times 1 over x. Okay? Now this is the same thing as this. It's just written differently. Alright? So, these will cancel out. I'm left with negative 1 over 4x plus 4. And we're going to find the limit. Now if we were to try to do direct substitution here, it would be negative 1 over 16, which is our answer. Alright, to sum up that problem, we started with this limit of a complex fraction. We tried direct substitution, but it came out indeterminate, so we had to try a different method. So I simplified the complex fraction by finding the common denominator and simplifying it, and then we could find the limit after that. Here we're given the limit as x approaches pi over 2 of cosine of x over cotangent of x. So first thing, when we're trying to evaluate limits, try and start easy. We'll see if we can just do direct substitution. So you have cosine of pi over 2 and cotangent of pi over 2. Now you can reference your unit circles from pre-calc, or you can try and graph both these functions, or you plug them in the calculator. But you'll see that cosine of pi over 2 is 0, and cotangent of pi over 2 is 0. And this again is indeterminate. So we are going to try and simplify the function so we can evaluate and learn something better about the graph. So you have cosine of x or cotangent of x. What is cotangent of x? Cotangent is 1 over tangent. also it's cosine of x over sine of x. Alright, so remember, if we're dividing, it's the same thing as multiplying by the reciprocal. So we are going to rewrite this fraction as two different fractions. So we have cosine of x, that's from the top, times sine of x over cosine of x. That's from the bottom. So instead of division, we're doing multiplication this time. So we took the top, we're multiplying by the reciprocal of the bottom. Now let's simplify. We got wink, womp. Yeah, that's simplified nicely. Now we're left with the limit as x approaches pi over 2 of sine of x. Now we just evaluate. Sine of x of pi over 2 is equal to 1. Okay, so we started with a indeterminate limit that we tried to simplify, and once we simplify completely, we just direct substitution. Alright, after watching this video and the previous videos, you should be able to tackle these 6 problems. So give them a try, and if you need any help, make sure to contact me.